I guess I can't full screen it, huh?
You should be able to.
Let's see.
What's your operating system?
I am on a Mac.
Yeah, should be straightforward. The controls just move around when you're full screen, so that can be confusing sometimes.
Okay, cool. Let me just, I'm going to turn off my personal videos. I did screen share. Did it start?
It did. I can see outline right now. Oh, you're not going to use your video. The video, your video is typically in the talk.
Oh, video. You mean the video feed of my face?
Yeah. It's your call.
Yeah, I prefer to leave it off. I'm having trouble with my internet today. We had a big storm here in Texas, and I don't want to overload my system and get kicked out in the middle of this.
Understood.
And sadly, that means that you all won't be able to see that I'm wearing my YAPC 2012 t-shirt.
I know.
Which I put on specifically for this, but I think it's better if I leave the video off, just so that I think what you all care about is the slides, right? So.
Okay, we are streaming and you're ready to go.
Okay, we want to give people a few minutes. I think this starts at 11, right?
Yeah, let's wait till 11.
Okay. So, anyway, let's wait till 11, then I'll start it up. Hope everybody's having fun with the remote. Hope that in the future we keep this remote as an option. I think it might enable more presenters. Not everybody can travel. It might be cool to have like in the future, even after pandemic, being able to do remote presenting is a good option. Not as much fun as live, but given the difficulty of travel and costs and everything, and
hello, can you hear me?
I hear somebody. I'm
Hey,
John. Who are you?
This is Brett. I'm the presenter.
Brett, you're in the wrong channel.
Oh, sorry.
I was just about to say, man, we could roll off for it. I got dice right here.
No,
but
sorry about that.
See you later. I can't be the only one with dice on my desk, right?
I have many dice.
So I can't actually see. Let me see if I can see the chat window somehow. Yeah, I can't actually see the chat window. So if people have questions, you need to shout it out and not be shy. Don't worry, I won't be offended. I guess we got another minute. Let's wait another minute. What kind of weather you all got in the places you're at? Here in Texas, it's been crazy. Cold, hot, rainy, all sorts of bizarre weather. Totally Mordor. Anybody out there got good weather now?
Yeah, it's hot in Toronto.
It's hot in Toronto.
Yeah, it's
pretty warm in the UK too.
Yeah.
It's in the 30s, which is I guess that's about 90.
Wow. 30 C, that's heavy. Yeah, high 90s.
It's
something
hot,
like that.
and it's humid. So
The-
I've had the AC running 24 hours a day for a while now.
In Houston, I'm not in Houston, I'm in Austin, but in Houston they call that dog breath weather. Hot, stinky, and wet.
Yeah, it's first thing in the morning, it's fine. You go outside about lunchtime, not so fine.
Yeah, I get up like at 5 something because it's the only time I can do anything. I used to be like Mr. Like the party doesn't start until midnight.
Yeah,
Now I'm up at 5 something. All right, looks like it's 11. Why don't we just kick it off? Oh, thank you. So hello, everybody, and hello for all my internet viewers, either live or in the future. My name is John Napiorkowski. I'm a Perl developer. I've been programming in Perl since the mid-90s. Guess I shouldn't say that, aging myself, but there you go. And I've been using Catalyst for about 15 years, give or take. I know, and I'm going to assume that people that are watching this know a little bit about Perl and know basically what Catalyst is. If you're a Catalyst beginner watching this video, you may want to look for something else because this probably is not an overview, a basic overview of Catalyst. I'm making some assumptions that you know what Catalyst is and Perl is, and that you've played with it. So that's just setting expectations. So anyway, so Catalyst is a web model view controller framework for Perl. It's been around for a long time, and I've been supporting Catalyst applications at several companies over many years, and I've seen a lot of like decently written applications. I've seen a lot of messes, and I've seen a lot of both mixed together. And my intention here with this presentation is just to talk a little bit about some of the patterns and anti-patterns that I've seen in Catalyst, things that work, things that didn't work, so that if you're supporting a Catalyst application, or if you're starting building a new one from scratch, which is cool too, these are things to keep in mind. Of course, this is my dogmatic viewpoint. Feel free to argue with me. Now, I got a lot of slides here, but I don't actually care if we get through all of them. If we get on a certain slide and you all want to like talk about that one for 20, 30 minutes, that's cool. Don't be shy about asking questions. I can't actually see the Zoom chat window for some reason while I'm presenting. So if you need to ask a question, just shout it out. I can't see that. If somebody starts typing it, if somebody could watch that chat for me, for those people who are shy and prefer to type, somebody keep an eye on the chat and let me know if chat questions come in. Does anybody want to volunteer to watch the chat for me?
I can watch it for you, John. This is Jay.
Hey, Jay, thank you. Cool. Okay.
You're welcome.
All right. So if anything comes in, otherwise, just shout it out. Again, like I said, I won't be insulted. And I'm more than happy to like not get through all these slides. All right. So let's, again, I'm assuming you know Catalyst and Perl and all those kind of things. So what's the outline for today? It's actually very simple. I'm going to talk about design patterns, Catalyst, and I'm going to talk about the most common anti-patterns that you should try to avoid and some ways to avoid them. Okay, so we're going to start with design patterns. So what's a design pattern? This is a big conversation in computer science and programming. The basic idea is that it's basically a formalization of a good practice to solve the types of common problems that we all face. Now, that's not to say that it's the only solution to solving the problem, but what I found is that when you're writing an application in Catalyst, and you have an application that's been around for 10 years or more, in which case many are, it's better to settle on common practices, even if you all don't agree that that's the best way to do something. Because what has killed applications the most, in my experience, is when people have 20 different ways to do the same thing because they couldn't come up with one way that was acceptable, okay? Now, again, that one way may not necessarily be the best possible approach, but it's a good common approach that makes sense and has some pragmatic experience behind it. So what are the very common design patterns that are in Catalyst? So one design pattern is called the command design pattern. And the command design pattern is basically, it's a complex set of behaviors represented by an object, and it's exposed as a single function. And the concept of a command pattern is it's going to abstract everything needed to perform a particular action. Now, when would you use a command design pattern? Generally, it's really useful for things. The most classic example that if you read the design pattern book, it's going to be like we're doing things like the undo buffer. Now, we don't have that in web development, but any kind of behavior that is cross-cutting and not like really strongly coupled to a business, to the business logic, maybe things like authorization, authentication, logging, all these things are cross-cutting concerns, and you could consider encapsulating them in a command pattern. Now, how is the command pattern used in Catalyst? So you're all using the command pattern all the time in Catalyst when you write an action. So who wants to tell me what is the action here in this piece of this example code? What's the action?
List.
Thank you. Okay, so right, it's basically in Catalyst, an action is just a method that's been decorated with an attribute to tell the application how this particular action is mapped to a URL. Now I'm using using a very simple, just like this is going to map to the list URL. Okay, and this method here, list, as you know, you put all your logic inside the function, but actually behind the scenes, when Catalyst sets itself up, it grabs this function and it wraps it in an action object, and that action object has an API that you can work with. Okay, and the primary method that it has is for things, it wraps how to execute and how matching happens. Okay, it has a couple other things there too, but the two most useful ones to link into are going to be matching and execute. Okay, so here's an example of so here's an example of an action. Okay, that what I'm trying to do here is I'm trying to say I want this action to match only when the incoming HTTP scheme is a specific scheme, either HTTP or HTTPS. So there's logic here. Unfortunately, you need to wrap both match args and match captures, just simply because captures and args do slightly different things, but they have the exact same API. So you can just cargo cult this around here. Let me show you the example how this is used, and then we'll go back to the code. Okay. So here's how you might use it. So I'm augmenting my action by using the scheme, does scheme. So again, oops, this is called a Catalyst action role scheme. And again, I'm including it with does, and then I'm adding some additional information. I'm saying what is the URL scheme that I want to match. Okay. So in this case, this gives you the ability to say, to customize how your actions will actually match an incoming URL request. Okay, let's go back to the code real quick. Yep. All right. So I'm just simply pulling out the URL scheme. There's actually a PSGI environment for it, and I'm just simply returning yes or no. So basically, match args, match captures. You have to return a Boolean. If the Boolean that's returned is true, then the action will match, and if it's 0, then the action will match. If the action doesn't match, then the system will just move on to the next most likely action to match it.
I have a question.
Question, yes.
Where does CTX come from?
That's excellent. That's a typo in my code. It should be C. Yes, but it's the Catalyst context. You're correct. Thank you for pointing that out. And that line here at the end, self-origin, CTX, that should actually be C. I prefer to say CTX over C just because it's harder to, when I'm writing my code, because it's harder to actually make a typo. I see a lot of people hit like V instead of C. That's a very common typo that I see. But for the purposes of this demo code, I just changed it to C because that's how most of the Catalyst docs are, and also it just took up less space, so I could get more code into my example. So that's an error.
Okay, no worries.
No problem. Does everybody understand? I mean, I'm assuming then again, like I said, I assumed you know a little bit about Perl and how Catalyst and Moose works. So you all understand like what around here is doing and how Moose role works and all those kind of things? Or does anybody need me to go through that quickly? Cool. So again, here you can do any type of composable execution or matching that you want to do. For example, like if you want to add some code around authorization, authentication, it could go in here. If you want to add some like logging, right, you could do that here as well. So it's cross-cutting concerns. Any other questions about the command pattern as an action in Catalyst? You can always shout it out later or hit me up on IRC. So that one was a little boring. Let's look at a little more interesting one. So this is the big one, ModelViewController. ModelViewController, it's considered a design pattern of design patterns because it in itself can encapsulate several design patterns underneath it. And the idea here was to separate your concerns for handling business logic, abstracting business logic from user interfaces. And it was originally written for desktop GUI applications. And in a desktop GUI application, it's often represented this way. Unfortunately, since HTTP is request response, unless of course you're doing something like WebSockets or something, we end up doing a slightly different version for Catalyst to work. So in the classic MVC, you have a user agent is interacting with the view via a controller. So they hit the controller and they send their controller a request, do something, right? The controller then is responsible for abstracting and handling all aspects of understanding what that request means, and then signaling a model for the requested changes, whether it's displaying something or changing data. And in classic MVC, the model and the view are bound so that when the model changes, the view automatically updates, and that's what the user sees, okay? On the web, it has to be a little different because we don't have a persistent connection. So in the web context, we tend to think of the controller as handling both manipulating the model as well as manipulating the view and returning the view to the user. So that's a slight difference, okay? And what we'll see is in Catalyst, your intention for the controller is to abstract and hold anything that has to do with the web request, okay, goes in the controller. That way, your models and views can be as abstract as possible. So let's get to some real examples, okay? So here's an example. It's a user controller, and it's simply, the point of this controller is we are asking a user model for a list, okay? We're getting a list of users. And again, here, since again, the view is not persistent, right, in HTTP, it's response request. So it's, the controller then itself has the responsibility of mapping that user model data to a view, okay? So that I'm just simply saying, all right, here's my list of users, and I'm saying view, here's the users, do your thing. And let's look at the view. I'm sorry, let's look at the model. The model here is actually just very simple. It's just, here's a list of users, just a list of names, Srinivas, Joe, and Holly, and the view is next. So again, I just wrote a view by hand. Obviously, in real life, you can use like a templating system, whether it's XLED or a template toolkit, or if you're doing JSON stuff, you'll be using one of those. But for the purposes of just like showing how the view works here, we're just simply showing, all right, the view is just returning some HTML. It gets the user list that was sent from the forward, and it's responsible for composing the response. Now, again, in general, it's thought that it's best to use the controller as much as possible for interfacing between the request and the response. But traditionally in Catalyst, we delegate to the view a certain amount of ability to actually create the response. So we allow the view to do things like create the response body, and typically to set response headers, like what the response is, the content type is going to be, and so forth. Okay, so as much as possible, things to do with like munging and understanding the request response should go into the controller, but the bits that are reusable can go either into a view or into a model. We'll show an example of a model a little bit later. Anybody have any questions about this piece of code before I move on? So this is a very simple, like here's the controller, very simple model, very simple view. And this ends up, then the user gets to see the list. Excuse me. Okay. All right. So that's the generics of ModelViewController. Let's move on to chain of responsibility. So chain of responsibility is another design pattern. And the concept of a chain of responsibility is when you have like a complicated workflow, instead of having one big method to try to handle everything, you want to try to decompose the responsibilities into discrete callable methods. Now, this is a reuse pattern. And usually when we think of reuse patterns, we think of object orientation, we think of inheritance, and in Perl using moose or moo, you might be thinking of roles, okay? But because the web frameworks and working with the web, it tends to be sort of a pipeline thing, right? Like the request comes in, you do some stuff, you build a response. Each of these are discrete steps, right? You might have some authorization, you might have some authentication, and then some authorization, et cetera, et cetera, et cetera, right? So these are individual discrete steps. So the chain of responsibility pattern actually fits, I think, the web a little bit better than classic thoughts of reusability with roles and inheritance. So let's look at an example of this. Okay, so in Catalyst, we can break up a request across multiple chained actions. Okay, so in this case, a request will come in. It will first hit the root action, and then depending on whether the request is a get or a post, it will either go to the summary list action or to the add action. Excuse me. I'm going to pause here for a moment and talk about chaining. I understand that a lot of people find chaining complicated. It's actually not that hard, okay? What you need to think about is there's two parts to the chaining, okay? There's the chained attribute, which refers to the action name that you're chaining from, or in the case of the first element of the chain, it's just the slash. So you can see there where it says root chain slash, that means it's the beginning of the chain, okay? Then down here where it says summary list, it says chained root. Now, one thing that gets people confused sometimes is they don't realize that the value of chained is supposed to be the action that you're chaining from, right? People have a tendency to think in terms of URLs or URL parts, which is fine. But in the case of chaining, that value for chained it should be the name of the action you're chaining from. Now that name can be a relative name or it can be an absolute name, okay? So in this case, I'm using a relative name. It's relative to the current controller, okay? But you could easily chain from a action in a controller in a different namespace by just simply putting in the full or additional relative namespacing information here, okay? And path part, now path part changes a little bit because path part actually refers to the part of the URL that you're mapping, okay? And then finally, args or Captureargs. Captureargs indicates that it's not the end of the chain, whereas args means, yes, I'm at the end of the chain. Okay, so that's why root is saying Captureargs, whereas summary list and add are saying args, because those are endpoints. Okay, and in any case, you could add anywhere from 0 to as many capture bits as you want. Okay. Do you have a question about that? I'm sure you must, because I know people always have questions about chaining. You're all very shy today. All right, well, let's just move on. If you come up with it later on, feel free to stop me. All right, so just to go through it. So we'll see here, a request will come in. And if it's a get, it goes first to root and then to summary list. And then if it's a post, it goes to root and then to add. And we're breaking up the responsibilities here by saying that first we're creating a view called summary list, and we're populating with items. Now, both summary list and add need that model. Okay, they need that view. But in the case of get, I'm simply saying, okay, just go ahead and HTTP OK, display it. Whereas if it's a post, I'm going to be doing some validation on the incoming post and saying if it's okay or if it's a bad request, right? So in this case, we've broken up the responsibilities of preparing the view from what to do with the view, okay? Now, you can use this to break up your logical flow that helps promote reusability. If you didn't have chaining, what you would end up having to do is you'd be preparing that view in both methods separately. So you would have repeated code. Questions about chaining or responsibility? Okay, now let's talk about Catalyst components. So what's a component? You use components all the time. A controller is a component, a model is a component, a view is a component. All three inherit from the Catalyst component base class, and a component is basically, it's just an abstraction that allows us to separate how an object is created from the use where that object is used. So here's an example, okay, of not using a component, right? Let's say you know that you need to get a result set of users, a list of users. And in order to do that, you need to get the schema object and connect it to a database. So you could do this, and you could repeat it everywhere you need it, which would, as we all know, not be the best thing to do. You'd end up with a lot of repeated code. And in addition, if you needed to do something like change the database or point the database someplace else, you would have to fix this code everywhere, okay? Additionally, it's got some other downsides. As you can see, this controller becomes tied to DBI as well as DBDPG. So let's just say someday in the future, you move from Postgres to some other storage system, okay? At which point, all your logic has been tied to a specific implementation, right? So in your code, to the degree that's reasonable and possible, you want to avoid tying your code to an implementation. You prefer to tie it to an interface. An interface can be re-implemented. If you tie it to an implementation, obviously you have to change all your code. So here's what it looks like, and what you're probably used to seeing it used, looking like when you do Catalyst. So here, I don't need to use DBI or DBD or any of the other bits. I get to remove that code. So my controller is not tied to that. And I am not implementing or creating the schema or anything. I'm just simply saying, give me a user model. And I'm going to abstract into the user model all the necessary bits. So this is just a quick overview of what a Catalyst component sort of looks like under the hood. It's got actually a number of methods, but the three methods that we care about the most, the first one is config. Config handles any like application level settings for your component. So for example, a good example of an implementation of a application setting would be things like your database password, right? Because that doesn't change while the application is running generally. It lasts for as long as the application runs. Now, generally, when you're doing this in Catalyst, you won't put those kind of things directly into the component. You'll put them in either in your application class or in a configuration file. But the configuration method is here. And then you have two other bits of component. The first part is the component method. This method gets called when the application is set up, okay? And it's expected to return a class, which is then considered an application singleton, right? Optionally, you can, in addition to having a component, you could add an accept context method. When you have an accept context method on Catalyst component, what that does is it makes it so that you can tweak your component per request. So what does that mean? Something that's an application scope might be something like a connection to your database, right? Because that doesn't change. Something that would be context-based, that might accept context, would be a model that would validate incoming parameters to make sure that they're valid, right? Because that changes for every single request. You'll have different parameters, right? So you can use either one or both in concert to build components that map to the life cycle that you're looking for, either application life cycle or request life cycle. As I said before, everything's a component in Catalyst, including controllers. Generally, we leave controllers as singletons because we just want to avoid the overhead of creating a new controller every single time. But there's no reason why you couldn't. I just generally don't. Okay. Let's just see what the time is. I'm kind of running short, so let's move through. So I mentioned there's a component lifecycle, and that's controlled by whether, and generally it's going to be whether or not you have accept context. Okay. If your component only has does the component method, that means that its life cycle is the life cycle of the entire application. Every time you call for that component, you get the exact same one. Okay. And since you're getting the exact same one, you really don't pass arguments to it because the arguments are useless. So here's an example of a model that would be useful from the context of application. You might have a model that represents the licensing information, copyright versioning information about your application. And this doesn't change while the application is running. You might configure it this way. Remember, I said that your configuration usually goes either in the application class or into a standalone configuration file. So let's see how that fits. And here's how you might use it in a controller, right? Somebody requests the info method and you're going to give the version information. Again, this never changes during the life cycle of the application. But what about when you want to have a model that does change on the per request and it can know about the request? As I said, maybe things like incoming parameters. Well, let's look at an example of something like that. So I've taken the previous one and I've made it a little more complicated, okay? And we've added an attribute called total requests. And this model accepts context. And as you can see here, it looks at there's a variable, a global variable in the Catalyst application class called count, which just basically keeps count of the number of requests that have happened during the entire life cycle of the application. So it's got a couple of bits here that never change, and then the request changes. So that's why it needs to accept context, because that's going to be different every single time. Just going back to here, what I mean by a factory component. In this case, you can see I'm saying return new on the actual model. Generally, it's better to abstract your model into a standalone class. Okay, so here I have my app model application meta factory, right? That's what Catalyst knows about. And it's saying accept context. And it's returning an instance, not of my app model application meta factory, it's returning an instance of my app application meta. So the reason you'd want to do this is, ideally, you want your models and views and everything as much as possible to be standalone, so that it's not tied into Catalyst. You're using your model as a proxy for that underlying concrete class. Just to show you what the concrete class looks like, it looks like this, right? And it's not under the Catalyst namespace at all, right? It's just a standalone thing. This is nice because it makes it easier for testing as well, by the way. Like you can easily write a test case for this, whereas writing a test case for this is much harder because you have to create an instance of Catalyst and you got to do a bunch of other things, okay? It also is cool because you can change the implementation here. Now, this is a very simple class, but just imagine it might be complicated. It might be something that's backed by a database, right? And you might be using, say, MySQL for your database, and then someday you get smart and you want to change to Postgres, right? Then you can change it here at your class level, and it won't actually break anything in Catalyst, right? Because you've separated out your actual implementation from the interface. So the interface is version, license, copyright, total requests, and any methods that it creates. Whereas your implementation, this is your actual concrete implementation. Does anybody have any questions about what I mean here by the differences between a concrete implementation of something versus using mapping the interface? Wish I could see people's faces, because then I would know if you're confused or not. By the way, can somebody shout out so I know that I'm still connected? My internet's kind of shaky. Somebody just say like, yeah, I'm here.
Yep, you're good.
Yeah,
Everything's fine.
Thank you, thank you. All right. So just a couple bits on components. Just remember, a context, if we were redoing Catalyst from scratch, we probably would only have context scoped components, because a context scoped components can be used to build any other type of scope, including application. This was the approach that Sri took when he did Modulicious. In general, everything is called, from what I can tell, everything is called in what we would call except context scope, and then he just returns, makes global variables and stuff for when something is meant to be an application scope. It's this way in Catalyst because application scope came first, and except context scope was an idea that was added in afterwards when it turned out to be useful. But there's one thing that's really handy about it, is that it makes it so that you can actually create a class in your application scope and then have that class return a different class in context scope. And that can be used for doing really interesting, complicated things that you might want to avoid unless you really need it. But in any case, your main goal here is you want to separate the wiring between all your bits. One thing to watch out for is watch out for performance, because again, this is Perl, it's an interpreted language. You could easily end up creating tons and tons of objects this way, and that might kill performance. So that's something just to keep in mind. And just again, repeated. Context scoping can be used to build any other type of scope, including something. So what's another type of scope? So we've talked about application scope, and we've talked about except context scope, which returns a new model every single time, or view every single time you call it. What happens if you want to? You might want a model that endures for the entire request cycle, right? In other words, every time you call for it, you get the same one, but only for a single request. So this is what the code for that might look like, right? In this case, what I'm doing here is, yeah, I'm looking here, and if the model exists, I return it, otherwise build it, okay? This is actually a really useful pattern, and because it's useful, it's been abstracted into a component role, which you should be familiar with, Catalyst component instance per context, and it basically just, you just do you have to implement a method called build per context instance. Then this is basically, it returns to you either a new instance of what you're calling for, or if it's already been created once during the life cycle of the request, it returns the same one. That could be confusing. I know one of you must be confused about that. Don't be shy. Ask me a question.
So like if you just spin up a foo out of nowhere, these things don't look familiar to me. Like if you do the starter package and create a foo app,
Yeah,
I don't recognize these things from the scaffolding that it builds.
sure. I mean, unfortunately, the scaffold, yeah, I mean, it would probably be ideal if there was like a totally new like Catalyst book or Catalyst like how-to thing. I don't have time to write it myself. If somebody wants to work on that with me, please hit me up on IRC and we can build it out. Yeah, I mean, unfortunately, a lot of these, when that stuff was written at the very beginning of the Catalyst project, a lot of these ideas hadn't popped up yet. As a result, when they did pop up, people implemented them, documented them on CPAN, and then moved on with their work. I mean, yes, no doubt the project does suffer from a lack of volunteers to keep all these best practices and documentation up to date with all the examples. You know, we do the best we can, but I mean, the Perl community is small. Most of us who do Perl are working full time, and it's, you know, difficult to keep it up. But yeah, sorry, I know you've probably never seen this before then. Yeah. Well, I'm showing it to you now. Nobody else has got any questions? I'll send Bitcoin Satoshis to anybody who asks me a question. Just send me your key address.
Do I get Satoshis for the questions I've already asked? Or do I get more if I ask more?
If you ask more, you get more. Yeah. Just send me your key. I'll send anybody who asks me a question a couple Satoshis.
Can you go back to the slide where you showed the chained actions?
Sure, of course. And like I said, I don't care. We don't have to get through all these slides. I just go over the bits you want to talk about. This one, is this the one you mean?
Oh, that one, yes. Why are we passing 0 to capture args and args?
Okay, awesome. By default, when you say capture args or args and you don't specify a number, that means capture as many as possible. As in other words, it'll match 1 to as many, right? And you might not want that, right? So it's unfortunate that that's the default. Like I think, like when you don't specify, most people think that should be none, right? But it's better to be pedantic. So it's like, why are you even saying arg0? If I mean none, just not saying it, shouldn't that be good enough? Unfortunately, for historical purposes, when chaining got added on to Catalyst, because args already existed, they needed to do this for backward compatibility. I've actually tried to write layers on top of chaining that help with this to try to make it more sane. And I considered showing that here in this presentation, but I decided not to because I guess it could be, I mean, it's my opinion, it's controversial. I wanted to stick to the by the book stuff, but there's very little doubt in my mind that the syntax for creating chains is not as obvious as it could be. And happy to work on improving that with anybody who wants to play with it at a later time. I actually have some prior art on CPAN that I use and I think work pretty well, but I didn't want to show that here because this wasn't going to be a presentation on show off all of John's CPAN modules.
Thank you. I didn't mean to derail the talk.
No, that's not derailed. That's the question. Like I said, I don't care. We don't have to get through all these slides. Does anybody have any other questions about this stuff? So where were we? Come down. Okay, so we were here, Catalyst component instant for context. Lifecycle questions. You could always hit me up on IRC later. Okay. Oops, wrong direction. So dependency injection. What is dependency injection as a design pattern? So again, the idea of a dependency injection is you want to separate how an object is created from how it's being used. And the upside to doing that, it adds some complexity, but the upside to it is that it allows you to abstract away your actual concrete implementations of things from how they're being used. So that makes it easier for you to change how something works under the hood without breaking all your existing code. Okay, so here's an example of some business logic. You may or may not be familiar with HTML form handler, but HTML form handler is a system made by Gerda Schenk, who I used to actually work with, for doing validation, okay, and for creating user interfaces. Just check the time here. I got a couple minutes. So basically, it just simply is saying that you're required to have these fields, name and password. So how might you want to bring that into? Here's a way to bring that into Catalyst, right? So you have that again. You have your concrete implementation. You have a model, which basically is a proxy for bringing that exposing that concrete implementation to a controller, and it here is encapsulating all the bits that it needs to do. Again, you may not be familiar with form handler, but form handler just takes a param options, which in this case is the body parameters of the request, and it does the validation work. So here I'm just basically encapsulating all the details about how that works, so that if someday we want to move from form handler to something else, we can change it here without having to change it in every single controller. So here's it is in a controller. So in this case, I'm just simply calling it, and I'm expecting it to just simply work. So again, don't write a model, write a class, and use a model adapter or do injection. To make this easy, on CPAN, we have Catalyst Model Adapter, which will encapsulate the three most common patterns. The application, which means one model for the life cycle of the entire application. Factory, which means give me a new model every time I ask for it. And per request, which is sort of a mix. It's like factory in that it will create a new instance every time you call, but it will only do it once for the duration of the request. So the first time you ask for it in a request, it'll create it, and after that, it uses the same one. I would encourage people to look at Catalyst Model Adapter on CPAN, but this is just a simple example of it. I'm creating a base concrete class, which encapsulates a schema requirement. Then I'm exposing it to Catalyst here, and I'm simply using it in the controller. And this will allow me to separate out the use of that entities model and the actual implementation of the entities model from how it's being used. So you could totally change it. Again, like you might be using DBIC, and then you may change to like using Elasticsearch or MongoDB or something else under the hood. And you don't have to, it doesn't break any of your existing code, as long as you've been very careful to properly isolate your implementation details from your public exposed interface. All right, I got a couple of minutes. Any questions about that? Excuse me. Let's see if we can hit some, and I got a couple of minutes, right? Let's hit an anti-pattern, my favorite subject. So one of the more commented anti-patterns in Catalyst is crazy complicated controllers. So we often hear about don't prematurely optimize. And when people think of premature optimization, they're generally thinking of performance, right? You know, you don't want to prematurely optimize the performance of something, because that in order to do that, then often means you end up with obfuscated code, right? But there's another type of premature optimization, which I call premature task optimization. What that means is, so here's an example of a controller that's been, in my opinion, prematurely optimized for task, okay? Somebody has been presented with a business case, and they've broken it up into a base class and a bunch of roles, right? And they think, wow, this is awesome. I followed the commandment, make thin controllers that don't do a lot, but which is cool, okay? But in order to do that, they've taken the task that they've been given, the business logic task they've been given, and broken it up so much that if that business logic changes, it's now very, very difficult to figure out what to do, right? And my recommendation here is to sort of, you know, you do want thin controllers, but don't go so wild with like base classes and controller roles. I actually myself, and this is maybe heresy, but I very, very rarely use controllers for anything other than namespace collections, and try not to do a lot of this kind of thing. And the biggest reason is this: when you go to work on something in Catalyst, you have a problem, you've been given a bug. The first thing that you would usually do is say, well, okay, what's the URL that the bug is being presented at? And then I want to go look at the actions that are connected to that URL, right? And if I have to open up 5 classes to figure that out, that makes my life as a debugger very difficult, right? So you don't want to make it too hard for somebody to find your entry point into the problem, okay? And thick controller is the other more common one. So that's an example of a thick controller, right? Tons and tons and tons of logic and thought in the controller. Now, of the two, if I had to choose one that I had to deal with, I would rather work with thick controller, because thick controller at least has one upside, which is I only have to open up one file to see everything, right? So if you're going to if you can't figure out what to do and you're not sure, you know, I know that, again, you hear the commandment, make your controllers thin. But if you can't do a good job of that, making your controllers a little thicker is probably like the better bet than over breaking up your controller logic, okay? Because at least, again, the upside here is I at least can see everything in one file. So again, when people say thin controllers, a thin controller doesn't mean a controller with fewer lines necessarily. What it means is write controllers that do controller things. What I mean by controller things is mapping request information to models and views, okay? And maybe doing some munging, like you pull in the parameters, maybe you need to change the parameters a little bit, then do some validation, and then send those parameters to a model to update a model, and then take that model and send it to a view, okay? All those things that are part of controller can be in there. If that makes a lot of lines, that's okay. If again, a thin controller doesn't mean a controller with fewer lines. It means a controller that only does specifically controller things as much as possible. A thick controller in my mind is stuff like a controller with a lot of SQL in it, or a controller that is building views. This is basically what I just said. And I think I got 30 seconds, so I'll just jump into it. The other problem that I often see is overuse of the stash. So here's an example of problems with the stash. Can anybody who wants to shout out and earn a couple Satoshi? What's the problem here? I think I got 15 seconds left, so be quick. Nobody sees it?
Typo in items.
A typo, right, yeah. And this is actually impossible to, like, this would actually kill you if you were over, because it would be very, very difficult to find, right? So I reckon you can't avoid using the stash in Catalyst. I've tried, like I've actually went and tried to build applications that didn't use the stash at all. And it ends up being worse. So you can use the stash, but use it intelligently. And one thing that I often do, and I'll show this and I guess I'll stop because time is up. And sometimes what I'll do is I'll map the stash to a model. So you can see what I've done here. And the model will sort of act as a sort of a strongly typed stash, right? So instead of passing to the view the stash, I'm passing to the view a list model, okay? And just to show you what that would potentially look like, it just might look like this, right? And so in this case, I'm avoiding the problem of typo, because if I mistype the method name on list model, that would actually give me an error, like when the code is running, right? Because it would be a method that didn't exist. Whereas in this version of it, the code would just continue right along, and it would really kill you. Other problems I've seen with the stash is like people use it so much. Like I've actually worked at companies where they had to have a wiki page to track all the stash variables, right? Okay, like when you're doing that, you're probably overdoing it. And again, one way around that is to do these request scoped class models to like encapsulate data for you. And I think I'm out of time, so I'll just simply stop. Anybody want to hit me with questions? That was pretty much it anyway. Doesn't have to
Great
use one.
job. Thanks, John.
Thank you. Nobody's got any. You can ask me questions unrelated. No.
You want to tell us about anything about the future of Catalyst, or not during this talk?
I think I've sort of used up my time. I don't want to. That's a really kind of a big topic. So we can.
Catalyst
If anybody
is
wants,
not dead, I guess. That's the point.
if anybody wants to talk about like the future of Catalyst, feel free to chat me up on IRC on the Catalyst system. I would be happy to like go over it with anybody and see what they have to think. All right, anybody, for those of you that earn Satoshi by asking me questions, send me your Bitcoin address and I'll send you a few. You can hit me up on, I think there's a Slack associated with this, or just send them to me on IRC. Cool, thanks everybody for showing up. And for those of you viewing this in the future on YouTube, I hope the future is awesome.